Okay, so in this poorly drawn picture, we have a woman who is 1.5 meters tall and walking away from a lamp that's 15 meters high. And the rate at which she's walking is 3 kilometers per hour. So this rate, let's see, dx over dt is 3 kilometers per hour, which unfortunately is not the same units, but it's easy enough to fix. So that would be 0.003 meters. What am I doing? 3,000 meters. I was dividing by 1,000. 3,000 meters per hour. And we want to know what her rate will be, or what the rate of the shadow growing. How fast is the shadow growing when she is 3 meters from the lamp? You know, I feel like this should be measured in seconds, and so let's go ahead and change this to 3,000 meters per 3,600 seconds, which is the same as, 15 over 18, which is 5 over 6 meters per second. That feels a little better to me. Okay, so we'll go with that. Okay, so we want to know how fast how fast is her shadow growing, which means what's the rate at which y is getting bigger? So for part A, I want to know what dy over dt is. So to do that, what we're going to do is set up a set of similar triangles. So we have the triangle that the woman makes with her shadow, and then you have the larger triangle that is made with the lamp. So let's go with the triangle with the woman first. Y over 1.5 should equal x plus y over 15. So we have that relationship between the x and the y. This is going to allow us to figure out what y is at this moment in time, this snapshot that we're taking here. And so when x equals 3, you have y over 1.5 is equal to 3 plus y over 15. This is convenient. I can write 10y over 15 is 3 over 15 plus y over 15, which gives me 9y over 15, which means that y is 1/3. So at this moment, this snapshot, we have this situation, 1/3 of a meter. It's very short, but it's going to get bigger. Don't worry. Okay, next we're going to use this relationship. So that's, we figured out what y was at that moment. So use this relationship. So we're going to differentiate with respect to time. And I get 1 over 1.5 dy over dt is equal to 1 over 15 dx over dt plus 1 over 15 dy over dt. So this is a straightforward relationship. Let me just clean things up. What are we looking for? We're looking for dy over dt. And so if I move the dy over dt over, let's see, this will be negative 1 over 50. Let's just multiply everything by 30. We'll clean up everything, 15. Multiply everything by 15. Here we go. I'll do that. And that gives me 10 dy over dt is equal to dx over dt plus dy over dt. That's better. So subtract dy over dt from both sides. And that gives us this, that dy over dt is 1/9 of dx over dt. So dy over dt is, the shadow is growing at a rate that is exactly 1/9 the speed of the woman. And so let's plug in the known values. Dy over dt, I guess this doesn't matter, or the y didn't matter, like where y was, how big it is. So 1/9 times 5/6, which is going to be 5 over 54 meters per second. We could have done that with kilometers per hour, but it just feels better to me with these small distances to do meters per second. So you can see meters per second. It's hard to see kilometers per hour. Okay, that's part A. Part B, what rate is the tip of her shadow moving? Okay, so when we're talking about the tip of the shadow, we have to think in terms of a different quantity here. And so I'm going to call that z, and I realize that z is just x plus y. There's z. So, so now we have the following relationships. So we have z, so this is part B. Z over 15 is equal to, I guess we know what y is, y over 1.5. Now we can do the related rates here. So this will be 1/15 dz over dt is equal to, I guess, 1 over 1.5 times dy over dt. Here again, I think it would be easiest if we multiply by 15. So dz over dt is equal to 10 dy over dt. And I guess that answers our question, because you have dz over dt is 10 times whatever dy over dt is, and it's irregardless of where you are, how far you are, it's 5 over 54, so 5/54, which is going to be 50 over 54 meters per second. All right, let's take a look at this flat plank lying against the wall. Let's see if I can draw this correctly. So you have a situation like this. Here's the wall. This is changing. Let's see the things that are changing. This is changing. The height of the, let's get rid of that. This is changing. Call that y. But this is not changing in the middle here. This is 41 feet long. I see from part B that we're going to need the angle. So the angle is changing. All right, let's go to this. We have, I just realized back here there's an easier, well, maybe easier. Let's just talk about this real quick. Sorry to back up to this. I'll put a big or here. That z is equal to x plus y. So dz over dt is just going to be the sum dx over dt plus dy over dt. Just so you know, you could do it this way. So that's 5/6 of a meter per second plus 5/54 of a meter per second, which presumably will be the same 50/54. Let's double check. 6 times 9 is equal to 54, and so 9 times 5 is 45, plus the 5 gives me 50. Yeah. Excellent. Okay, getting back to this. Sorry about that little interlude. Okay, so what is happening here? This thing is moving down, did it say? Top of the plank is initially touching the wall. 39 feet above the floor. So top of the plank starts to slide down at a rate of 5 feet per minute. 5 feet per minute. At the 6-minute mark, okay, so here's the thing. At t equals 6, the height of the plank, so the plank starts out at 39, but we're moving down at 5 feet per minute times the 6 minutes. And so the plank will be 9 feet above the ground. So this is not a very good picture, but we're going to go with it anyway. I guess we could figure out the angle as well. Maybe we should figure out what x is now that I've got that 9 there. So x squared plus y squared. This is, by the way, the relationship we're using. But we're going to actually plug in 9 for y. So, squared there. So x squared plus 81. 41 squared, I should know this. But offhand, I'm going to actually pull out my calculator because I want to get it right. So give me a sec here. It's 1681. That would have been easy. Okay, so that means that x squared is equal to 1600 and x is equal to 40 because 40 squared is 1600. So this snapshot, this moment in time that we're looking at this, that's the situation. And so now let's actually do the related rates. So this will be part A. Oops, not that. This part little a, interesting. There's capital A up there. Little a. Oops. Keep 40 here. Okay. Little a. Finally, we want to know what y over dt is. So let's go ahead and do the dx over dt, or we have this relationship. And now we're going to do the derivatives. 2x dx over dt, derivative with respect to t. 2y dy over dt is equal to 1681, which is going to go away in just a minute. Oh, no, derivative. Derivative of a constant is 0. Now let's plug in what we know. 2 times 40 times dx over dt. It's dx over dt that we don't know because we know what dy over dt is. -5 feet per minute. Okay, so this will be plus 2 times y times -5 feet per minute. Then we're going to just solve for x, or dx over dt. So this is going to be 2 times 5 is 10, times 9 is 90, over 80 feet per minute. Next, we're going to compute the angle. So you can use whatever tool you'd like, but in order to avoid the, that is any trig function will work here. But in order to avoid some of the pain that I'd have to endure to figure out some of this, I'm going to try to avoid using x. And so the the sine. Sine is opposite over hypotenuse. Is going to be y over 41. So that's what I'll use. So over here for part B, sine of the angle is, let's move this over, y over 41. And so the derivative, cosine of the angle, times d theta over dt is equal to 1 over 41 dy over dt. Let's plug in what we know. We need to know what the angle... Oh, actually, we can figure out the cosine of the angle, can't we? At this moment in time, when y is equal to 9 and x is equal to 40, theta is equal to the arc cosine of 40 over 41. Interesting. So we could use that over here. So the cosine of the angle is 40 over 41 times d theta over dt is equal to 1 over 41 times 5. That means d theta over dt is equal to 5 over 40, which is 1 over 8. And the units there are going to be radians per minute. Technically, the angle radians is not there's no units for that angle because, yeah, it's a confusing thing because you're dividing. If you follow all the units here, you have, let's see, I'll do it. I'll follow them. No. Where's my... There. Okay, so where are units? Okay, so the sine of the angle, let's see, the cosine of the angle. Okay, so that's going to be unitless because you have 40 over 41, so there's no units there. This y is measured in, was it feet? And 41 is measured in feet. dy over dt is feet per minute. That's bothersome, isn't it? Oh, I see. The y went away when you did the derivative. Okay, we're good. Yeah, so this is feet per minute. And this is feet. Yeah, 41 feet. 41 feet, feet per minute. And so the feet cancel. This doesn't have units. Well, you can think of it as feet over feet. Well, whatever. So it is radians per minute, though. At least that's what we tend to say. Okay, that's enough of that. Okay, one more. Let's see. So we're going to be using logarithmic differentiation for this. So we're going to call this y to the g of x. And so the natural log of y is equal to the natural log of f to the g, if you'll forgive me for leaving off the x. And that means the natural log of y is equal to g of x times the natural log of f of x. Now let's go ahead and do our derivatives using implicit differentiation. Y prime over y. Natural log of y, derivative is 1 over y, but then you multiply by y prime. And then this is going to be the product rule. So I have g prime of x times natural log of f of x. I did not leave myself enough room. Let's move this over. Okay. Plus g of x times the derivative of the natural log, which using the chain rule, you get 1 over f of x times f prime of x. Now we can plug in what we know. I guess here, y prime is g prime ln of f of x plus g of x, f prime of x over f of x, all multiplied by y, which is f to the g. Now we can plug everything in, and I didn't leave myself or you very much room, but I think we can handle this. So essentially, I want to know y prime at 3, which is going to be g prime at 3, natural log of f at 3, plus g at 3, f prime evaluated at 3, f evaluated at 3, all multiplied by f at 3 to the g at 3. Okay, so minimal amount of work now to do. I'm going to have to move things around one more time. Lovely. Okay, we're given all these quantities here, f of 3 and g prime. Let's see, so this will be, I'll see if I can clean things up. 4 times the natural log f of 3 was 2. And then g of 3 is 5 times 7 over f of 3 is 2. So I'm just matching things up here. Like this f of 3 is that, and the g of 3 is 5, and so on. Okay. Nearly done now. And then f of 3 is 2, and g of 3 is 5. Let's finish this up. So that's going to be 32. 32 times 4 is 128. Plus 30 times 16, because some of those 2's will cancel. So that's 480. Oh, does this have a unit? No, it doesn't. There. That's it.